All right, chemistry guys. So we are going to go over that page 20 in the book. Um, for those of you that are going to be working on this homework tonight needs some extra help. So this shouldn't take too long. Let's just dive right in and see if there are some questions you can have that I can answer. So question number 5, it says if we have an additional proton and it's added, would we still have the oxygen atom? So if we start with oxygen and we go to our table from above, we had 8 protons. Now if we added another proton, we'd have 9 protons. And if we remember from that work that we did on that table, protons give us the identity of the atom. So if we go from 8 to 9, no longer do we have oxygen, but we have fluorine. Remember that this number here, the number of protons here, is also the atomic number on the periodic table. So we can go to the periodic table and figure out what element it is by looking at the number of protons. Now we can do the same thing with oxygen. Let's say we have oxygen, and so yeah, referring to oxygen, if we look at oxygen here, it has 8 protons. These are protons, we'll put them here, protons, and it also had 8 electrons. Now we're going to change it so that we're adding an electron. And oxygen is still going to have the 8 protons, but now it has 9 electrons. Still has the 8 protons, so it's still the same element. But because of the 9 electrons, it now has a charge. And that charge is going to be -1. Lastly, if we have a neutron, would it still be oxygen? Again, we're going to do select black. Oxygen here. There we go. Had the 8 protons, 8 electrons, and it also had 8 neutrons. Now, if all of these stay the same, we still have our 8 protons, we still have our 8 electrons. We now have 9 neutrons. And this means that we would still have, we would still see that we have the 8 protons, so it's still oxygen. The neutrons, though, here indicate that we have a different mass number. So that's going to be the change here. Up above, all of these had mass numbers of 16. Yeah, let's do mass number 16 here, and this now has a mass number of 17. And so that's the change. Let's go into the table here. I'm going to erase that. Scroll. There we go. Got it. We're looking at this table here, and this is a table that it would be really common to see on an assessment, a quiz or a test or something like that. It really organizes where things are and the role of those subatomic particles. So we have protons, neutrons, electrons. The location, we have 2 options. Either it's going to be the nucleus or the electron cloud. And we have nucleus for these 2 guys. The protons and the neutrons are the things that have mass. And they are located in that very small point in the center of the atom called the nucleus. The charge here is a +1. No charge -1. Now, if you remember the size of the marbles that we used for that activity, if protons have the relative mass of 1, now relative means compared to each other, that means that the neutrons are also going to have a mass of 1, because 1 and 1 are the same, just like the size of the marbles. The electrons, though, were very, very tiny, and so tiny we're going to say that compared to the protons and neutrons, they have a relative mass of 0. Now the role. So the protons give us the identity. That tells us what the atom is. If we change the number of protons, we change the identity of the atom. The neutron changes the mass. If we change the number of neutrons, we get a different mass number. And electrons, finally, is the charge. Now we have a paragraph that summarizes everything that we worked on. The number of proton gives it its identity. The number that corresponds to the protons is called the atomic number. Carbon has 6 protons, and therefore its atomic number is 6. So atomic number is number of protons. Atomic number, number of protons. The number of electrons determines the charge. For example, calcium has, I better look this up, 20 electrons if it's neutral. If calcium gained a positive 2 charge, it would have 18 electrons. Now maybe we need to look at that here really quickly, because that's really an important concept. So I'm going to put that right in this little blank spot. If calcium has 20 protons and 20 electrons, can I get the protons from the periodic table? That's the atomic number. Calcium with a +2 charge will have 20 protons. We cannot change the number of protons. If we do, we change what the element is, and 18 electrons. So if we subtract electrons, we gain a positive charge. And we gain a positive charge equal to the difference. So 20 minus 18 is 2, so it's a +2. If we look at, say, oxygen, so I'm going to do a break here. Oxygen starts off with 8 protons, and oxygen with a -2 is 8 electrons. We have 8 excuse me, that's wrong. Let me erase this, guys. Not sure what I was thinking. Still has 8 protons. Because it's still oxygen. 8 protons, 8 protons. Here we have 8 electrons. And here we have 10 electrons. So again, the difference here is 2. But we're increasing the electrons. And so we get that -2. There's the +2. So, and if this was 9 electrons, then it'd be -1. If it was 11 electrons, it'd be -3, because it's equal to the difference. All right. Neutrons have no charge. However, they are still important. Besides the protons, neutrons are the only other subatomic particle that has mass. Again, these are the ones that have mass. Therefore, the mass number of an atom is found by adding the protons and the neutrons. All right, I'm going to erase that. Go ahead and move this up to the very bottom part. And go through question number 10, which is also another really excellent kind of quiz or test question you could see, is based on the information given, could you tell if it's an element or not? Is it possible to determine the identity of the element given the information below? Yes, identify the element. No, figure out what else you would need in order to figure this out. So the first one, 16 protons, yes, because that equals the atomic number. So go to the periodic table and look that up. It's going to be sulfur. An element with 12 electrons, this is no. We need the charge. If it's neutral, that means that we're going to have 12 electrons and 12 protons. Then we could do it. Then we could figure it out, and this guy would be magnesium. But since we don't know the charge, we can't figure out if it's magnesium or not. All right. An element with 14 neutrons and a mass number of 24, this is yes. And that is because protons plus neutrons is equal to the mass number. If we have the mass number as 24, or the number of neutrons, it's 14, we can figure out that the number of protons has to equal 10. It's just chemistry algebra, right? We're going to move the 14 over so we can isolate our protons, and we get 10, and this turns out to be then neon. Number D, an element with 35 electrons, and that it is neutral. That neutral part, super important. That means that this is yes, because we know that it has to have the exact same number of electrons. We have 35 electrons. Since it's neutral, there has to be 35 protons. And there we end up with our final answer of, I gotta look this up. Bromine. You'll notice, ladies and gentlemen, that I do not have the periodic table memorized, and I do not expect you to have it memorized. And that should finish things up. We get to the table, we'll talk more about that in a different video. Thanks, guys.